In the last video, we talked about evaluating exponential functions. In this video, we're going to learn how to graph those exponential functions. So for our first example, I'm going to rewrite this equation, f of x equals the opposite of 2 raised to the power of x, as the opposite and 2 raised to the power of x, just so that I know I'm not taking negative 2 to the power of x. I'm doing the opposite of whatever 2 to the raised to the power of x is. Now when you make a table, you do not have to put this middle column in, but for the sake of this video, I want to show you how you would do this all by hand, since on some tests and quizzes, you are actually asked to do it by hand. So let's take some values, negative 2, negative 1, 0, 1, 2, and 3. Now why did I choose those values? With exponential functions, you want to get just a range of things to put in there. So your basic negative 2 to 2 would work. I'm going to put in 3 just to get a little bit more of the curve here. So if I'm evaluating negative 2, I'm going to have the opposite of 2 raised to the negative second power, which gets me the opposite of 1/2 raised to the second power, so I get negative 1/4. If I take negative 1, I'm going to have the opposite of 2 raised to the negative 1, so I have the opposite of 1/2, which is negative 1/2. If I take 0, I have the opposite of 2 raised to the 0 power. Now remember, anything raised to 0 is just 1, so I have the opposite of 1, so negative 1. Now I'm going to take the opposite of 2 to the first power, which is the opposite of 2, so that's negative 2. Opposite of 2 raised to the second power is the opposite of 4, so I have negative 4. The opposite of 2 raised to the third power is the opposite of 8, I have negative 8. Now I'm ready to plot some points. So negative 2 and negative 1/4, so over negative 2, down about 1/4. Over to negative 1, down about 1/2. 0, negative 1, 1, negative 2, 2, negative 4, 3, negative 8. So we should kind of notice that this curve starts to go down and go towards infinity. We also notice over here, it's starting to approach 0, but it's not going to actually get any greater than the negatives. So when I make this curve, it actually ends up having an asymptote at 0. If I were to plug in more numbers, I would end up getting more negative and close to 0, but never touch it. Looking at the domain, from left to right, I'm going to cover everything on this exponential function, which is true for all exponential functions. The range, again, I have everything down here, but as soon as I get up to 0, I'm going to start approaching 0 but never touch it. So my range is from negative infinity to 0, but I'm not including 0. Therefore, I have an asymptote of y equals 0, or the x-axis. So let's go through another example here with our constant e that we learned about in the last video. So remember that e is about 2.7 raised to the power of x. So when I do this, I can put this in my calculator and get some values, or I can just leave it as fractions. Let's try our basic negative 2, negative 1, 0, 1, 2. And we're going to take e to the negative 2. So I'm going to take 1 over 2.7 squared, which is about 1 over 7.4. Now I'm going to take negative e to the negative first power, which is 1 over 2.7, 1 over 2.7. If I get these decimals, I end up getting really small numbers. So you should just realize that it is approaching 0 with these values. Let's take e to the 0 power. We know anything raised to the 0 power is 1. So we have 1. E to the first power is about 2.7. And e to the second power is about 7.4. So now let's plot these. Negative 2 Again, we have a really small decimal. -1, we have a really small decimal somewhere in there. 1, or 0, we have at 1. 1, we have about 2.7. And 2, we have all the way up to about 7.4. So we kind of realize that it has that curve. It's going up, and it'll keep getting bigger. As it goes to -infinity, it's going to approach 0 but not touch it. So our domain for this graph, again, we hit everything. Our range for this graph, we don't have any negative values, but as soon as we cross 0, we have everything. So 0, not included, to positive infinity. Again, the asymptote, y equals 0, or the x-axis, whichever one you would like to call it. So here is my question for you to think about and bring to class tomorrow. Is the function f of x with 1/2 raised to the x power and the graph of f of x equals 2 raised to the negative x power the same? So are these two functions the same exact graph? Be prepared to kind of explain your reasoning behind that.